So let's summarize what we have learned by looking into each aspect of a capacitor post introduction of dielectric between them. So we have a condition that the battery is disconnected and the charges are present on the capacitor. So we have a charged capacitor, and in between that we are placing dielectric. So what will happen to the charges per se? They will remain the same. Why? Well, where will the charge go? As simple as that. Once the battery is disconnected, there's no external circuit for the current to flow, charges to flow to or from the capacitor. So it will stay there. What will happen to the electrical field? This we know, it will obviously reduce. We have been doing that. By what factor? This also we know, by a factor of K. So E new is equal to E initial by kappa. Not K actually, it's kappa, but yeah, you guys know. Potential difference, obviously again, correct, it will increase. No, it will reduce, right? Think about it. It has to reduce. The potential difference by a factor of, again, correct. So this we can find it with help of this particular formula. So V nu is equal to E nu into D, and this is E naught by kappa D, and this numerator is your V naught by K. What about capacitor? Of course, it increases. By what factor? K. So this too is quite simple. So C is equal to Q by V. In this case, Q is same as Q naught by V. V we just know that it is V naught. So Q naught by V naught into K, and that's nothing but your C naught K, right? As simple as that. What about energy stored? Well, it's kind of common sense. It will reduce by a factor of, again, K. But why? Well, the energy is used up in doing something with the slab, and that is to polarize. So let's try to prove it. So V is equal to half, I'll use CV square, I guess. So we know the expression for voltage, we just saw that, and we know the expression for C naught. C, that is C naught K, and this is, this will reduce, right? V naught by K square. So this and this will cancel, and say this is half C naught V naught square by K. And this entire thing is nothing but U naught by K. Agree, guys? So let me summarize this for you guys. Overall, what happens? Initially, when we have C naught and Q naught, C naught being your capacitance, and the voltage is quite high. Once we introduce a dielectric, what happens? We have seen this diagram. It reduces. So this is V naught. This will become V naught by K. What will happen to the charge? It will remain to be Q naught, and the capacitance will increase by K. Okay, so what else can we write? Then, so strength and all that you guys know. So U naught to U naught by K. What else can I write? I think that's good enough. Okay, guys. So we are looking at what happens to the quite a few factors when we have a dielectric placed between two parallel plates of capacitor that forms a capacitor.